This tutorial is about how to form chemical formulas, and it'll focus on ionic formulas. A chemical formula of a substance shows the chemical composition, that is, it shows how many atoms of each element are present in a molecule or formula unit of a compound. Now you can just have elements, where you just have free elements, which are monoatomic. Examples of iron, potassium, zinc, so on and so forth. You get diatomic elements, and it's good to memorize those. You got hydrogen, which is H2, oxygen O2, nitrogen N2, fluorine F2, chlorine Cl2, bromine Br2, and iodine I2. And those always come in twos. You can have some more complicated elements. For example, that ozone there, or you got P4, which is a form of phosphorus, S8, which is a form of sulfur, and there are several of those. And you can certainly have more complicated compounds. H2O is water, C6H12O6 is glucose, and the list goes on that. So if you look at a formula, can you tell how many of each type of atom is in there? For example, in that water, you've got 2 hydrogen atoms and 1 oxygen atom. Notice there are 2 subscript on the hydrogen, but no subscript on the oxygen. The absence of a subscript implies a 1. In H3, you've got 1 nitrogen atom and 3 hydrogen atoms. Carbon dioxide, you got 1 carbon atom and 2 oxygen atoms. Now here we got a calcium nitrate. We can see a calcium there, but the NO3 is in parentheses. So that nitrogen there's 2 NO3, so that means there's 2 nitrogen atoms to the 1 calcium atom. But then you see the 3 inside the parentheses for the oxygen, so 3 times 2 is 6 oxygen atoms. You got 2 nitrogen atoms and just 1 calcium atom. So that parentheses, you need to be careful and look at how many of the whole unit there is and multiply it out. Now, moving on to ionic compounds. Ions are atoms or groups of atoms that possess a net electrical charge. The positive ions, or the cations, have 1 or more electrons removed. You have monoatomic ions like a sodium ion with a positive 1 charge, a calcium ion with a positive 2 charge, aluminum ion with a positive 3 charge, or you can have polyatomic ions that are positive, such as the ammonium ion. Those polyatomic ions are molecular combinations of atoms, except they all have a net charge. So negative ions, or anions, have 1 or more electrons added. They can be monoatomic, like chloride with a negative 1 charge, oxide with a negative 2 charge, or nitride with a negative 3 charge, so on and so forth. Or they can be polyatomic, like sulfate, SO4 negative 2, or nitrate, NO3 negative 1. You'll find the list of anions is much larger than the list of polyatomic cations. Now you can use the periodic chart to determine the charge of certain elements, particularly in the A groups. 1A is +1, as you can see, 2A is +2, 3A, for example, aluminum, +3. Not a good hard and fast rule for 4, but for 5, -3, for 6, -2, for 7, -1, and 8A, they typically don't form ions, and so that column is, of course, blank, and theirs has 0 charge. Now, for the B groups, what we see is that in many cases there are multiple charges possible. And even some of these metals that are after the transition metals under those A groups, like tin and lead, can have multiple charges. Those are the two most common, of course. And so we don't have a whole lot of good hard and fast rules for them. And so you'll have to deduce what their charges are based on the context. So rules for writing formulas for ionic compounds. Your ionic compounds are combinations of metal ions or positive polyatomic ions with mono or polyatomic anions. The positive ion by convention is written first, and the anion is written second. Then we're going to add subscripts on these ions so that you get a net charge for the compound to be 0. We want the charge to cancel. And since you can have more than one set of subscripts that yields a net 0 charge, we want that to be the smallest set of whole numbers possible. It can't be fractions or decimals, but whole numbers, but they want to be the smallest set possible. So let's write some formulas. So if we've got an aluminum with a +3 charge and an oxygen with a -2 charge, we need to find the least common denominator. Least common denominator is a good way to think about how to figure out what the common ratio is. That is, what is the smallest number both of them go into. And in this case, 2 and 3 go into 6 evenly because they don't divide into each other. So 2 times 3 is 6, and 3 times 2 is 6. So I need 2 aluminums to get to 6, and I need 3 oxides to get to 6. So my formula is Al2O3. And that correctly balances the charge, and that's the smallest set of whole numbers possible. Alternatively, you could use an algebraic equation like 3x minus 2y equals 0. In this case, you could plug in a large set of numbers into that, and it'd be solvable because I have one equation and 2 unknowns. But again, 2 and 3 are the smallest ones that can go in there, and so we'd still say 2 and 3. Okay, we want to find the correct formula for calcium +2 and sulfide -2. What we find is that they have the same charge, so in all likelihood we'd have one of each. And in fact, that's what we do get, and we have a formula of CaS. Now, if we have zinc +2 and nitrate, a polyatomic ion with a -1 charge, we find that -1 goes evenly into 2, and so we can see that we have 2 nitrates and 1 zinc ion. Again, the cation's written first, so the correct formula would be Zn, and then since nitrate's a polyatomic ion, we put it in parentheses and then put a 2 on the outside. Notice none of the charges show or anything like that. So we put parentheses around that to indicate there's more than one nitrate ion. This has been a short tutorial on forming chemical formulas, and with a focus on forming of these ionic formulas.